Hello class, we are going to come to the second lesson. By the way, I apologize for my accent first. I listened to myself and I realized it. I hope that you guys can understand. But anyway, try to ask questions if you do have. I put on the discussion board. And I'm going to do lesson number 2, which is 13.2. 13.2, we're going to learn how to, this is still for the class for March 16. This lesson is about how to find the limit, okay, and discuss the continuity. So this is basically 1A material, but it's for multi-variable calculus. So it's for 2 variables, but the idea is still the same. So for instance, let's look at point number 18. We want to discuss the continuity and find the limit for this function. Okay, the limit when x and y are approaching 1 and 1. And we want to know what is the limit equal to this x plus y. So we look at it, there's no undefined point here because the x and y approach 1 and 1. So you just need to substitute the number inside here. Okay, so that's equal to 1 over 1 plus 1, which is equal to 1 over square root 2. And so the limit is equal to 1 over square root 2 when x and y approach 1, 1. And for the continuity, okay, for continuous, we know the function usually continues at the domain. So basically, you just need to find the domain. So we know that x plus y, okay, it cannot equal 0, but it has to be greater than 0 here because it's inside the square root, so this has to be greater than 0. So x greater, so this function continues at the domain x, y, such that x plus y greater than 0. Okay, so the function continues in this domain. So this is for the number 18, and let's try another one. Okay, let's try point number 22. For number 22, we want to find the limit for this function x, y approaching 0, 1 and cosine inverse x over y divided by 1 plus xy. So we do the same thing. We put 0 and 1 inside here. Look at what happened. This just equal to 1, the bottom. Okay, on the top, cosine as x is equal to 0, 0 divided by 1 just equal to 0. So this is actually equal to cosine inverse 0. Okay, cosine inverse is 0 over 1. Okay, it's just equal to cosine 0. By the graph, we know that cosine is like this. Cosine 0 is equal to what? 0. Oh no, I mean it's cosine inverse 0, I'm sorry. Didn't look at it. Okay, cosine inverse 0 is right here. Okay, it's equal to power 2. Not cosine 0, sorry about that. So now we got for the continuity. Okay, for the continuity, let's look at it. Okay, how do we discuss? First of all, this one cannot equal 0. That's the first one. And so that means x times y don't equal to negative 1. So that's the first one. The second one, well, let's see. For cosine inverse, cosine is a bounds between 1 and negative 1, right? So that means this number cannot be outside 1 and negative 1. So that means x over y has to be between 1 and negative 1. Because you cannot take cosine inverse a number bigger than 1 or less than negative 1. So that's the second one. The third one we have to consider is what? you cannot have y equals 0 here because y equals 0, that will be undefined. So this y cannot equal 0. So that means this is three things you need to consider. Okay, as long as they are inside, follow this rule, then this will be continuous. Okay, so continuous as long as these all follow. So that's all you need to do for these problems. So that's for the first portion of this lesson. Okay, now we're going to go to the second pathway to find the limit by using polar coordinate, coordinate approach. Okay, because sometimes at some limit we cannot do it. Okay, like normally we couldn't put it inside. So for instance, let's look at this one, line number 15.4. Let's look at number 15.4. If we have xy approaching 0, 0, and x squared minus y squared over x squared plus y squared. Okay, look at this problem first. If we're going to substitute this number inside here, what happened? We're going to get 0, 0, 0, 0. So 0 over 0, right? So you get 0 over 0. And in 1a, we know that if 0 over 0, we can use L'Hopital's rule. But here we cannot because we don't know how to take derivative for a function two variable yet. So what do? We use the polar coordinate to approach. So let's record our formula. We know that x equal to r cosine theta, okay? Y is equal to r sine theta. So we said we're going to convert, okay? We're going to convert this one to in terms of r and theta. So we're going to change our xy, okay, to r and theta. So we go x equal to r cosine theta, I put it inside here. Okay, so I'm going to continue here. So sorry about that. So it's not long enough, so I'm going to continue here. So my limit here, xy to 0, 0 become r to 0. Okay, and then my x, so my x equal to r squared cosine squared theta minus r squared sine squared theta over, and I convert everything in terms of r and cosine, r and theta. So that become r squared cosine squared theta plus r squared sine squared theta. And we can see that this part, okay, you can take out the r squared. So that becomes r approaching 0, r squared, and then cosine squared theta minus sine squared theta over, now this part is equal to r squared, take out, this equal to what? 1, that right? Cosine squared plus sine squared equal to 1. So square root r squared is equal to r. So we use the cosine squared plus sine squared equal to 1. Okay, so you factor out the r squared here. So now this can reduce. And that's equal to r approaching 0. And r cosine, this is what? Cosine what? 2 theta. Okay, by using double angle to convert it. You don't have to do that, but it just looks a little bit nicer. Now when r goes to 0, this just equal what? 0. So that's how you do this problem, okay? So you can see it. The first of all, we convert everything. Now x, y goes to 0, okay? Because if this is 0, this is 0, that means r goes to approaching 0. So r approaching 0 here, okay? Then convert all the x and y, and then that's how you get convert all the x, y to r cosine, r sine. So that's for problem number 15.4. And let's try another one. Okay, let's try number 15.8. We have, okay, limit x and y approaching 0, 0, and sine x squared plus y squared over x squared plus y squared. And how do we do this? By using polar approach. So we're going to do the same thing, okay? Our xy go to 0, 0, that means r goes to 0. And then convert these to sine x equal to r cosine theta plus a square. Sorry, I forgot the square. So this is square. And plus r squared sine squared theta. And divide by, this is just r squared. So now take out the r squared also. So that becomes sine r squared over r squared. And now let's see. And what happened to this? Okay, now remember that when we do 1a, we have property, right? And the property we do in 1a is that limit x approaching 0 and sine x over x equal to 1. That right? So you can look at this, it's almost like that, okay? Or you can use L'Hopital's rule now because you only have one variable, okay? So you can use L'Hopital's rule if you want here. Because it's what? 0 over 0. And then if you use L'Hopital's rule, or you can use this one's equal 1, or you can use L'Hopital's rule, that's equal what? 2r cosine r squared over what? 2r. That right? So this r goes to 0. That reduce. So that's equal to limit r approaching 0 cosine 0. So that's also equal to 1. So either way, you're going to get a 1 as the answer. Okay, so that's basically for 13.2.